Pretty good, you?
Good. Are you still work from home?
Yeah. Actually, no, it's more hybrid. On Fridays and Mondays, we work from home. And the rest of the week, it's in the office. Tuesday,
Okay.
Wednesday, Thursday. Yeah.
That's a good system.
Yeah. It's been interesting so far.
Nice.
How about you?
And you're West Coast based?
Yeah, I'm in. You?
Okay, nice. Same.
Yeah, nice.
Yep. We're usually in the office. I had a 9:30 meeting and then a 10 meeting, so I was like, I'm going to take those from home and then I'll go into the office.
Oh, you're still going into the office?
Yeah, we go just about every day.
Okay, nice.
Yeah. Well, welcome. I don't think you've had an intro call with anyone,
No.
right? I'm your first?
No.
Okay. So I guess I can give a brief overview of and then we can ask some questions. And then at the end, I'll have a demo.
Okay.
So our core technology is clock synchronization.
Okay.
So you can take a group of virtual machines or physical machines, actually, and we synchronize their clocks to nanosecond level precision. We started as a group in Stanford, a research project in Stanford, and they were trying to synchronize clocks actually for a different project they were doing. And they realized that their algorithm for synchronizing clocks was actually pretty novel and pretty good. So that paper got published, and then they spun it out into a company. So our first employees, or our founding team, is a Stanford professor, and then a few Stanford PhD students who have since graduated.
Okay.
So since then, well, I like to think of it as like clock synchronization is our core technology and like our founding technology. And that product itself is pretty stable. There's a few tweaks that we need to make. Some of it we're making open source, which is a whole other beast. But like the technology and algorithm itself is pretty stable.
Okay.
And so we're trying to build out like different pillars, different applications that would benefit from clock synchronization.
Yeah.
So an example would be network congestion control. Normally for network congestion control, you just have to rely on what if you think the network is congested. But when you have super synchronized clocks, you can measure one-way delays and you can actually know for sure, like, okay, right now the network is actually congested. So you get a tighter control.
Okay.
Other examples, gaming, fairness in gaming specifically. What else? Distributed applications, so distributed snapshotting, distributed databases, all of those like have existing solutions for consistency, but they would benefit and you would get a better solution with clock synchronization.
Yeah, nice.
So we're a small team. Let's see, I've been here for about a year. We probably started, when I started, there was 8 people, and I'd say we're closer to the 20 range now. So we're growing quickly, but still a very small team.
Okay, nice. And what's the division between engineering, product, UX?
Mostly engineering.
Yeah.
I'd say, let's see, we have 2 admins, a UI designer.
What's an admin?
Just office admins.
Okay, gotcha.
Yeah, they do the hiring, they do make sure checks, they do lunch orders.
I've only been in big tech companies and they have very specific titles for every role. I forget at times that startups are more fluid. So
Yeah,
the titles can
very
technically
fluid.
sort of extend what their responsibilities are.
The guy who usually does the intro calls,
Yeah.
who he's out this week, which is why I'm doing it. But he says, yeah, he actually used to work at Google. And he said, it's weird. Sometimes I have to unload the dishwasher. Like, that never happens at Google.
That's funny.
Yep. Mostly engineers. I'd say engineering, at least half.
Okay, that's good to know.
Yeah. What else? Our first customers and like still our biggest use, which clock synchronization helps for. And then they're also like the exchanges are mandated by the government to have fairness, and part of the fairness is to have synchronized clocks.
Yeah.
So when they were on-prem, they had like fancy hardware solutions for synchronized clocks, but now they're moving to the cloud and they can't implement the fancy hardware solutions. So they need a software solution for synchronizing clocks, and that's where we step in.
Okay, so how did not existed? What would these clients have done instead?
They would have waited for the clouds to implement their own hardware solution.
Okay.
Which I don't think the cloud, I mean, I don't know what the clouds are doing, but like it's not like they're open about, oh yeah, we're implementing a hardware solution right now.
Yeah.
Or they would have used the current best of the best, which is not nearly as accurate.
Okay. So in the case of, was the sales strategy to clients essentially not going after the client of competitors, but instead identifying those who needed to move to a software-based synchronization for clocks and essentially just finding out who those potential clients were? I'm sort of trying to understand how did essentially find its market.
Yeah. My understanding, and this was before I joined, my understanding was the financial market was like, they are in a rat race of like who can get the best technology faster.
Okay.
And so like all of the companies, NASDAQ was our first customer.
Yeah.
And once they had it, then all of the other financial customers were like, oh, there's better clocks now. Like we need that because we don't want to fall behind in technology.
Okay.
So the financial industry, and we're still gaining clients in the financial industry, but they were kind of the easiest. I mean, they were the first and they were all like super willing and they understand the need for clocks.
Okay.
we're shifting, like that model is definitely like build up the relationships with a large company and like do a proof of concept, and it's slow and you get a big contract at the end, but it's like one by one and a little slow. So we're kind of starting to shift specifically with like gaming to, can we just open source something that developers will be interested in and they'll just pick up and have it spread and go for like adoption instead of sales. So that's kind of our next phase, and what we're trying to do next.
Yeah, that makes a lot of sense. And how do things look on the engineering side, get into that next phase?
That's been my project. So I'm only going to say good things, which is not true entirely. Let's see, we're hoping to launch in the next few weeks with an initial open source version. So I'd say that project is actually in decent shape. We're intentionally going for a little less accurate. So one, because it makes the design simpler, and two, because we want some motivation to go to the paid version. So it's open source, so we're not giving any like guarantees, and it will be a little less accurate. We need to do a lot of testing to actually understand how much less accurate that is.
And in terms of growing the team, how do you see the roles being filled in terms of what skill sets are you guys looking for and such?
Yeah, so I'd say like the two biggest groups you can hire are new grads versus experienced engineers. New grads have a ton of energy, but they know very little. But they're easier to hire. And then experienced engineers, like people who can guide a project and like understand how all the different pieces of a project fit together. And so we've had a lot of success with new hires, and we have a lot of new hires who are excited and ready to go. We're looking for people who can like, again, understand. I was able to consult the senior engineers of the company, but it was really like me working with two new hires, two new grads, need more people like that to kind of balance up the new grads.
Okay, that makes a lot of sense.
Yeah. Any other questions? You asked good questions.
Those are the main ones that came top of mind for me. I guess also, what does the tech stack look like?
Yeah, so it was originally in C++. So it's all software, and we distribute it to customers just as a Debian package, usually. So it's just a binary that they can install. It was originally C++, and most of the super low-level stuff has to be C++, like your control and clocks, which other languages just don't let you do. Most of it on top of that is Go, and we're kind of trying to shift to Go more and more, just because it's easier to maintain, easier to understand. I don't know. I strongly prefer Go.
Yeah, I'm curious. I've never used Go, but I've noticed in the past couple of years there's been a huge proliferation of using Go, and I've always been curious as to why. If you were to sell me as a more traditional C++ Java guy, Go being a lot more modern, how would you sell Go to me? As in, why Go?
So the benefit of C++ over other existing languages is it has a ton of low-level control, right? You get to know where the memory mapping is. You get to understand all of that. But it's a very complicated code base if you're going to write C++. And there's a lot of opportunities for concurrency issues, race conditions.
Essentially shooting yourself in the foot.
Yeah, exactly. So Go provides most of the control that C++ does, but in just a much more user-friendly way. So the concurrency primitives are much easier to use and much less likely to fall into any kind of race conditions. And then on top of that, anything that you can't do in Go compiles C++ code. So if it's like, oh, I need to control the clocks, then you just write the C++ code and Go uses that. So it's an easier to use systems language is kind of how I think of it.
Okay, that makes a lot of sense. Obviously, I know Go is dominated in a lot of respects, but I've only used Python, Java, and C++ here, so I've always just been curious.
Yeah. I just started a few months ago writing Go. Before that, I was doing a lot of data analysis, so that was just Python. I've really enjoyed Go. I really like that language.
I do enjoy the speed with which you can do things in Python, but I understand as you grow a big project and you have a big team, Python not having things like type safety without using external libraries and such makes it a bit annoying at times to collaborate with a big team.
Yeah, exactly. So for us, Python is scripting and data analysis, and then the actual backend is mostly Go.
Okay, that makes a lot of sense. Awesome. Yeah, that mostly covers the questions I had. Do you have any questions for me?
I do. I'm going to share a link with you. And then let me just find. So this is mostly, there's actually no coding. It's mostly just a thinking question. And I apologize, it's a lot to read, but this is the last chunk to read.
So two high-frequency traders NV submit orders to a matching engine. Whenever one of them submits an order, a timestamp taken on transfer is added to the order message for orders. Matching wishes to process these trades fairly and so runs to the sequencer and order processor. The sequencer and keys receive orders in a where earlier is 10 times behind. 1 plus 50 queues orders on the queue. Process only pulled off. Sign in queue for at least duration. Okay. Stream the party queue. You can method thing which will time. Central needs and orders when central. This clock is constantly 1 millisecond ahead of the reference clock. This clock is constantly 3 minutes behind the but it takes 10 to as much energy as you want. Okay, turns out which trade is first and why. Okay, interesting math. Let me see if I can parse this a little more simply. So two have submit orders to match engine, and one of them submits an order. Submit order leads to timestamp taken of trader's machine is added. Timestamp taken, trader machine added to order message for the order sent to match an engine. Seems like it's a sequence. We did a timestamp, add the order message, and then send order sent to match an engine. So runs 2 threads. Match engine is okay. Sequencer and order processor. Sequencer and queues. See the orders in a priority queue. The priority queue. Priority queue. Sequencer queues received orders in a priority queue where earliest intent to get high priority. There. And a priority. Well, the processor EQs orders from its queues. Ops orders from queue. Processor only pulls the top order of the queue this type in the queue for at least duration K. So let's order from queue if say order dot just in the queue. Let's say order dot duration is greater than at least greater than or equal to K. Assume the priority queue can be negligible time. So at the priority queue, it's off 1, it's negligible. Pop from, it's also off 1. Negligible. Say that trader B. Trader A, trader B. Say the trader B submits as a trader B. Submit order 2 milliseconds after trader A. Okay, so let's say trader A submit order at time, let's say X. So trader B submit order at time X plus, it says 2 milliseconds. So after trader A. Trader A's clock is constantly 1 millisecond against reference clock. Alright, so I'm going to say the reference clock. Time is, let's say Y. So we order time X, where X equals to, what is it, 1 millisecond ahead. So X equals to Y plus 1 millisecond. So trader A's clock is constantly 1 millisecond ahead of the reference clock. Trader B's clock is constantly 3 milliseconds behind the reference clock. Okay, I see. So we order time X. Clock, time. These are different variables now. Run out of letters. J, clock time. K equals to J plus this. And then clock time. 3 milliseconds behind reference time, so it's J minus 3 milliseconds. Order time. Okay. Order time takes 10 milliseconds to reach match an engine. Time A. So order time A. That takes X plus 10 milliseconds. 10 seconds. Reach match an engine. Trader B's order takes 12. It takes 12 milliseconds to reach match an engine. K is 12 milliseconds, which trader will be the first, and Y. Alright, so that equals to 20 milliseconds. Which trader's order will be DQ first and why? Let's go through this. Alright, so processor only DQs orders if it's in queue for at least K duration. So it has to sit in for at least 20 milliseconds. Alright, so party queue, let's order from the queue. Just so I better understand the third paragraph, are we saying in this example that trader A submits an order and then trader B submits an order 2 milliseconds after?
Exactly.
Okay. Trader's clock plus 1 reference clock. Trader's clock is behind reference clock. Let's go ahead. Okay, so we can get the time then. So that A time equals to.
I'm adding a new line, so I don't know if it's getting cut off for you, but it was for me.
Okay. Did you add the lines?
Yeah. Do you not see it?
Nothing changed on my side.
Oh.
Still see the 3 paragraphs.
Oh, sorry, at the bottom, just because it was getting cut off at the bottom. Anyways, continue.
Okay, yeah, I haven't said anything new. But let A time. Let me do something similar. So A's clock is constantly 1 millisecond ahead of the reference clock. So if A time is this, then let reference time instead of 1/9. B's clock is only 3 milliseconds behind reference clock. So let B time 3 seconds behind 1/6. Trade A's order takes 10 milliseconds. Let's say submits order at seconds. It takes 10 minutes to reach. Order reaches engine at 10 milliseconds. It takes 12 milliseconds to reach. Okay, so trade A submits an order this. That means E submits order at 2 milliseconds after trader A. So it's 3-2. Trader's order takes 12 milliseconds to reach. So that means order says reach mechanism. So that would be 4-4. K is 20 milliseconds. Shows what we do first and why. Alright, so let's only pull to the top. We'll close the board with Q for this one, Q for at least 20 milliseconds. That's real time. The second queues. Actually, I don't want to listen to that timestamp. Then to the order message before the order is sent to the machine engine. With that second and processor. Then queues received orders that priority or earliest and timestamps get priority when that's the week. So only don't count like this one. Assume the party queue and can take negligible time. Tradition that always when the internet clock only 1 millisecond ahead for reference clock. Trader E clock is constantly 3 milliseconds behind of Trader E order takes 10 milliseconds. First and only. Alright, so I guess the part I'm trying to understand is how does reference time, A time, and B time affect when the processor pulls the order?
Yeah, that's a good question. So this timeline
is
all one consistent timeline, right? So we can assume that's reference time.
Okay.
The timestamps are taken at the trader's machine before they're sent.
When you say, okay.
So even though A submits an order at 30,
Yeah.
That's in reference time. The timestamp might not show 30.
It's in reference time, not A time, which is 1 millisecond ahead of reference time.
Well, actually, that's a good question. I don't know if you meant this to be in reference time or trader time. Reference time or like A's time and B's time.
Okay, because if it says trader A's clock is constantly ahead of the reference clock, then any order trader A sets, you're saying that that order's time isn't looked at from A's time, but from the reference time?
No. So how do I explain this? So when we say that trader B submits an order 2 milliseconds after trader A, that's in reference time.
Okay. So let me try and parse it again. So if trader A submits an order, well, the matching engine is only looking at the reference time. Is that correct?
Exactly.
Okay. I'll make a note of that. So matching engine is looking at the reference time. That's a party queue that earlier, the height of already for duration. So trader B submits today's clock is 20 milliseconds. It's going to consult me reference clock. Trader's going to 3 minutes behind the reference clock. It takes 10 minutes to reach the matching engine. And line, where is it? 14, which says trader A's order takes 10 milliseconds to reach the matching engine. By matching engine, it means the sequencer, which then goes to the processor?
Yes.
Okay. So it takes 10 milliseconds to reach the matching engine. Trader only takes engine.
So let's say A submits an order at ref time 0.
Okay. Which means the reference time is 0 minus 1 millisecond.
What is A's timestamp of that order?
What is A's timestamp of that order?
Yeah.
Sure is it? By trader A's timestamp order, do you mean the time it takes to reach the matching engine?
Nope. So let's see, line 18, right? Yeah. You submit an order, and then you take a timestamp on the trader's machine.
Yeah.
Then the message gets the timestamp.
Yeah.
And then the order is sent to the matching engine.
Okay.
So when we say that A submits an order at reference time 0, right? A, before it actually sends the order, is going to add a timestamp to that order.
Okay.
What is the timestamp on that order?
Because I'm reading through this to see where it says it assigns a timestamp to an order. Then it says timestamp taken, but it doesn't say how.
Oh yeah, and then it's added to the order message.
Timestamp before we send it. Whenever one submits an order, a timestamp taken on the trader's machine. Okay, so if A submits an order at 0, a timestamp is taken on the trader's machine, which means A. Is that right?
Yes.
And it doesn't say how much time to submit an order. Okay, so I'm looking to see if it says it takes any time to submit an order. Because it says that to whenever one of them submits an order. It doesn't say it takes X amount of milliseconds to submit an order.
I see. So remember, it's reference time 0 to submit an order.
Yeah.
So the reference clock says 0.
Yeah.
But A's clock doesn't say 0.
A submits an order, reference time 0. Yeah, so what I was saying before is A's clock is 1 millisecond ahead of reference clock, so it would be at 1 millisecond.
At 1, good.
Yeah.
Okay, so then what time does B submit an order?
Yeah, so B.
So that's actually like how NASDAQ uses us, is you need synchronized clocks to ensure fairness.
Okay, that makes sense.
Yeah. And that timestamp is in the trader's time, because the trader only knows its own clock, and its clock is off.
Okay.
B submits the order.
B submits an order. B's clock is constantly 3 milliseconds behind the reference clock. So if A's reference is 0, B's reference would say -3.
So they have the same reference.
Wait, reference times 0. That's 2 negative. Where's 1? Okay, because I see the 2 millisecond difference.
Right, so if A submits at reference time 0,
yeah.
2 milliseconds later B submits. So it would be reference time 2.
Maybe I haven't played around with clocks enough because that sounds strangely obtuse, but okay.
So a reference clock, like, suppose there's this notion of global time.
Yeah.
Right, which
nobody knows. The confusion for me might be, this question is sort of presupposing that the terms are clearly defined, and that might be where my confusion was introduced. Because I think if you work at Clockwork, then you have a very clear understanding of what a reference time is and all of those. I think for me, seeing this problem for the first time, it wasn't clear at all. So it might have been why I was confused by some of this. I tried to sort of write it out on line 20 through, or is it 49? I'm not sure if there was any inconsistencies in here, but this is how I was trying to parse some of the lingo used, if that makes sense.
Yeah, that makes a lot of sense. We've asked this question to a lot of people at this point. I think the notion of reference, I think one thing we're trying to tease out with this question is like the notion of reference time and being ahead and behind is kind of a complicated thing. So we're trying to tease it out.
Yeah, because I guess the confusion is there are essentially 2 sets of numbers you're keeping track of. You're keeping track of actual clock times as well as the order times. And the clock times have different variables that control where the one's ahead of the other. And the order times have different variables in terms of if this one's sent at this time, then this one's sent either before or after. So I guess those are the 2 things that I'm trying to keep track of. And that's probably where the confusion came in, because it doesn't seem reference time. Yeah, I think one thing that would have helped, if anything, because I interview a lot of people as well, but more like coding specific software engineering questions, is usually we give 2 or 3 examples so you can probably understand how it should work. With this problem statement, because there's no example given, that's why I sort of had to write my own example, and there's probably some confusion in there. If I had an example of saying, like, let's say on July 24th, John submitted an order at this time, this is his reference time, then Carla submits an order at this time, and you can see the difference, then that might make things a bit clearer, but it might be also the intention of the problem to not give an example, to sort of go from the theory to the example. So I guess, yeah, it could really matter in what you're looking for testing.
Yeah. I think, so why don't I just jump to the end? So what ends up happening is B submits an order after trader A.
Yeah.
But because of the clock inaccuracies, B's order is prioritized over A's. So this is an example of a time when fairness is important, and clock GMs here running on GCP.
Okay.
And they are currently synchronizing their clocks using NTP, which is kind of like the state, not the state of the art, but the standard go-to. It's installed in most machines coming out of the gate to synchronize clocks.
Okay.
And we've installed our software as in these machines, but in what we call observation mode. So observation mode. So that's our clock sync.
Definitely very different from anything I've heard a description of. So.
In what way?
In the sense that I've worked in different areas in IoT, augmented reality, computer vision, but the whole concept of drilling down into the granularity of clocks isn't something I've really encountered before. I mean, obviously I'm familiar with financial institutions and the need for having very precise clock synchronization and order flows and stuff like that. But from a technical side, that's definitely something I've never considered much.
Yeah. It's interesting once you start going into clock sync, because there's so many things you want to do just to rely on time.
Yeah.
And you realize, well, now we can't rely on the time because we're trying to fix the time. So things like timeouts, right? You just want to say like, okay, in 5 seconds, if I don't hear from you, then you have an error, but you can't rely on the time. So it just completely changes how you think about the software that you're developing.
Yeah.
Okay. I didn't even get a lot of time to ask. Usually I don't do the demo and I don't do the intro. So I have time to dig into candidates' backgrounds. But Kent wasn't here, so I did the demo and I did the intro. So future people will definitely, like, I want to hear about your background, and I'll leave it to other interviewers to ask you about that.
Yeah, for sure.
You apply. I don't even know if you've applied yet, but definitely would love for you to apply.
Definitely. Yeah.
Okay, great.
All right, thanks a lot.
Yep, enjoy the rest of your day.
All right, bye.
Bye.